In 1990, the residential energy use in the United States was responsible for 962 million metric tons of carbon dioxide emissions. By the year 2000, the number had risen to 1,182 million metric tons. If the emissions grow exponentially and continue at the same rate, what will the emissions grow to by 2050? Assuming an exponential growth rate, we have our exponential growth model, P sub n equals P sub naught times 1 plus r to the n. We know our initial amount, and we can use either the 1990 or 2000. However, I'm going to use the 1990 because that will help me to solve for r. So we have P naught equals 962 million metric tons, and 10 years later we had 1,182. So we can plug that in to our model. We have 1 plus r to the 10 because it's after 10 years that we grew to that much. Now we can solve for r. We divide both sides by 962. We have 1,182 over 962 equals 1 plus r to the 10. Our goal here is to solve for r, so we need to get rid of this exponent. To get rid of the exponent, we can raise both sides of our equation to the reciprocal of that exponent, so that's to the 1/10. And that gives us just 1 plus r. Now to solve for r, we just subtract 1. So 1182 over 962 to the 1/10 minus 1 is equal to r. Plugging this into our calculator gives us approximately 0.0208 for r. Now that we know r, we can come back and plug it into our model. We have P sub n equals the 962 times 1 plus 0.0208, so 1.0208 to the n. Now we'd like to know what the emissions grow to by the year 2050. This is 60 years after our initial time, so P sub 60 is what we're looking for. 962 times 1.0208 to the 60. Now, it's important to know that we did use a rounded form here, so it might be better to not actually type in the rounded form into your calculator, but to use the exact form. And we could, well, that is, of course, just this, that 1 plus r is that 1182 over 962 to the 1/10, and then raised to the 60. And this will give us an exact answer when we plug this into our calculator. This gives us approximately 3,310, and this is in million metric tons.